This video is going to be about box plots. Now, I always learned them as what are called box and whisker plots, but I guess they dropped the whisker part and they call it box plots. But here in Minnesota, we still call them box and whisker plots a lot of times. But I'll just call them box plots. In order to make a box plot, first of all, you have to know that that's only for numerical, which is quantitative data. You have to have numbers. You have to have, in fact, what's called the 5-number summary. Those are going to be the 5 places where you put a number. So these are the most important 5 numbers, okay? They are the minimum, the first quartile, the median, the third quartile, and the maximum. That is your 5-number summary. Okay, so first I'm just going to give you a set of numbers and we're going to calculate the 5-number summary. Hey, here's my set. 10, 18, 17, 27, 19, 18, 12, 16, 23, 17, 10, 13, and we'll stop there. Now, I'm not finding standard deviation or mean, so it really doesn't matter how long the list is. It might be a pain in the butt a little bit to put them all in order and find these, but it's not that big of a deal. So again, since we are finding the minimum and the quartiles, these are measures of spread, then we have to put these numbers in order from smallest to largest and lay them out so we can find the spread. Okay, so I'm just going to do that on another board here. As you put these numbers in order, it's always a good idea to cross them off. So what I'm doing is I'm writing them down on another board. You would write them down on a piece of paper, for example. Please don't try to do everything in your head. That's one thing that just drives me crazy when I'm working with a student and they ask me about a problem and then I say, well, show me your work, and they don't have anything. I can't put these numbers in my head. I can't put these in order in my head. I can't. Doesn't matter how long I've been teaching, how smart I am, how much degrees in math I have. Doesn't matter. Can't do it. You need to actually write them out and find the one in the middle. So I'm just going to go ahead and do that. I've got 10, 10, 12, 13. Notice that I'm crossing them off as I go so I don't miss anything. Then I have 17, 18. Whoops, see, I missed a 16. It's always important to double check your work, to cross things off. 17, 17. 18, 18, 19, 23, 27. Kind of wanted to get them all on one line, but 2, 4, 6, 8, 10, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, you always want to count and make sure that you have all the numbers. Okay, so I needed my minimum, that's easy, 10. Needed my maximum, that's easy, 27. Highest and lowest numbers, 10 and 27. Now, remember, that means that with that, I can find my range. My range is just my max minus my min, so 27 minus 10 will be 17 for my range. Okay, now I need my median. You can't find your quartiles until you found your median. And you're going to, I don't really like the whole crossing off because then you've crossed off your number and you can't necessarily see them. But again, when I do this on a table, I don't literally write them all out and count. I just count how many numbers and then split it in half. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. 12 divided by 2 is 6. Since it's an even number, I'm splitting the list in half and there will be 6 numbers on the left and 6 numbers on the right. I'm not looking for the 6th number. I'm looking for the number between 6 and 7. 1, 2, 3, 4, 5, 6. Because there's an even number of numbers. Okay? 6 on the left, 6 on the right. Between 17 and 17 is still 17. So my median is 17. Now, Q1, first of all, is also called the lower quartile, first quartile, lower quartile, and lower hinge. They're all called the same thing. It's called a hinge. First quartile, lower quartile, left hinge or lower hinge. All right. What that is just the median of the numbers on the left. So now that you've split your data into 2 data sets, it's like you're starting over and you're finding the median of this side, that's Q1. Then you find the median of this side, that's Q3. So median of this side, there's 6 numbers. I need the number that splits it into 2 groups of 3. 3, 3. So that is halfway between 12 and 13 is 12.5 is my first quartile. Okay, same thing here. There's 6 numbers. I need so it splits it into 3 and 3. So it's going to be right here between the 18 and the 19, which means it's 18.5 for my third quartile. Now what I've done is I've split this data into 4 groups. That's why they're called quartiles, because quartile comes from the word qua, which means 4, like 4 quarters in a dollar, 4 quarts in a gallon. Qua, 4. So quartile, 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 quartile. And what that means is that each of these quartiles holds 25% of the data. 25% of the data is here, 25% of the data is here, 25% of the data is here, and 25% of the data is here. Each quartile holds 25% of the data. Now, what we're going to do is we're going to actually make our box plot out of this. Once we have our 5-number summary, making our box plot is fairly easy. We're going to, they should be made on a number line so that you can kind of see the realism of how spread apart they are, but I'm not going to have a real number line here. I just know that it has to go from 10 to 27, so I'm going to kind of, I don't know, I'm going to count 8, I'm going to count by twos, 8, 10, 12. It's sort of up to you how you do it or how it's already laid out for you. 18, 20, 22, 24, 26. Actually, I didn't have enough room. Okay, I don't like when I do that. So I'm going to have to erase this real quick and make a new one. I'm going to have to go up to 28. So I'm going to go 8 to 28. 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Okay, now I have a number line. And my minimum was 10. So here's how you do this. You put a dot at 10. My maximum was 27, so I put a dot at 27. Now remember, I didn't really have a 27 because I went by twos, but that doesn't mean there's not a 27. It just means I didn't label it. It's between 26 and 28, obviously. My median is at 17, same. My median is not going to be a numbered value on the number line, but it's still there. My first quartile is 12.5. 12.5 is not just halfway. Halfway would be 13. It's going to be halfway there. So this is why you might have wanted to use something that's counted by ones instead of by twos, but that's okay. If you're given a number line, just use it. My third quartile was 18.5, which remember, halfway between that would be 19. So don't go halfway between that, but you want 19.5. All right, now I've got my 5-number summary. This still isn't a box plot, though, because you need a box in order to have a box plot. And the box goes from Q3 to Q1 or Q1 to Q3. So I draw a box. And this is why they are called hinges, because I don't know why exactly, but these are the hinges. These are the Q1 and Q3, the ends of the box. So this is at 12.5, Q1, hinge 1. This is at 18.5, Q3, hinge 3. And the dot in the middle is the median, which technically is Q2. There's our box. Our box goes from Q1 to Q3 with the median. I'm not going to say in the middle of the box because it's not in the middle of the box. It's just wherever the data is. Notice it's not in the middle of the box. That's because it's going to have some skew, which I'm going to talk about here. But the median is this line. And then you draw a line from the hinges out to the maximum and the minimum. And that's where Minnesotans call those whiskers. So that would be my box and whisker plot. Okay. I'm taking it off of the number line so that you can see it a little bit better because it was a tad messy. It looks like this. Box and whisker. When we look at this, 25% of the data is between 10 and 12.5, 25% of the data is between 12.5 and 17, 25% of the data is between 17 and 18.5, and the last 25 is between 18.5 and 27. This is a hinge, this is a hinge. Now, we can look at this and see that it's not symmetrical. Symmetrical means that everything would be perfect. Here's a symmetrical box and whisker plot. In a symmetrical box and whisker plot, guess what? The median's in the middle. Guess what else? The whiskers are the same size. Now, I didn't draw that perfectly, but this is clearly more symmetrical than my last one. This is supposed to be symmetrical, where each quartile is the same size. Each of these holds 25% of the data. We know that. But in this one, we can see that this data is not symmetrical because this is what's called skewed. Okay, skew. Now, I'm going to come back to that in a minute. We're going to look at this in a minute, but I want to define skew for you first. All right, skew is when the data is not symmetric. So we have two different kinds of skew. We could have what's called left skew. We could have what's called right skew. And we could have no skew. Here's my three skews, okay? This one is supposed to be symmetric. That means that these, what are called tails, and this, which we're going to call the bump, are pretty much equal, okay? This is what's called a frequency distribution or a polynomial distribution. I'm sorry, not a polynomial. I meant polygon distribution. That doesn't really matter that much. What this means, though, is this is symmetric. You'll often see this later as what's called a normal curve, but it's only normal if it's symmetric. Keep that in mind for later. What this does mean, though, is that this highest point is where the mean equals the median equals the mode. If the mean, the median, and the mode are equal, then the data is symmetric. Our box and whisker plot will be perfect. It will look like this little dude where everything is split evenly, okay? But that's not very realistic. In fact, most of the time data is skewed, unless we do something called normalizing, which we'll talk about later. That's a different chapter, different semester actually. But we're going to be looking at these. This is what's called left skew, also called negative skew. Left and negative are the same. This is called right skew or positive skew. You know what? I just realized that I drew these two the same. Oopsie daisy. Left skew or negative skew means that this tail is on the left, and I'll tell you why in a minute. A lot of people want to think where the bump is the skew, but it's not. It's where the tail is. This tail is longer than this tail, so this tail is left skewed. And I meant to draw it so this one is right skewed. There you go. The right skewed is positive skewed. That means that the tail is on the left, and that means that the bump is on the tail is on the right and the bump is on the left. Sorry, I'm getting that mixed up. Okay, now let me explain why. In a symmetric distribution, the mean, the median, and the mode are equal. That would be like if I gave you a quiz out of 10 points, I gave you 4 quizzes, and you got 7, 8, 9, 10. 7, 8, 9, 10. Perfectly distributed. You got 1 in each of the quartiles. If I split it up, my 7, 8, 8.5 would be my median. These two would be on the left. These two numbers in here split would be my quartiles. It would be perfectly split evenly. But if I gave you a quiz and you got 10, 10, 10, 7, you already know what would happen. Your average, if you got 10, 10, 10, 10, your average is going to be 10. Add them all up, divide by 4, it's still going to be 10. That's what you're looking for. You want to have them all be high. But if you get one low score, you already know that what's going to happen is your average, your mean, is no longer going to be 10. It's going to be pulled down. Why was it pulled down? Because your number pulled that average down. When it pulls it down, it takes, instead of all this being centered like this, my 7, 8, 9, 10, I now have my 4 10s, my 1 7 is pulling this data like this. It's pulling it, so my mean is now going to be smaller. My median's still going to be here, but my mean is now going to be smaller than that. It's no longer that perfect 10. It got shifted to the left because one of my numbers was smaller. So that means if my data is left skewed, it means that my mean is less than my median. Now think about that the opposite direction. If you're normally a 7 student and your scores are 7, 7, 7, 7, you know your mean is 7. But if you get 7, 7, 7, 10, just the opposite, you know that your grade is no longer a 7. It's now going to go up. 7, 7, 7, 10 makes your average higher, and therefore this tail is going to be pulled this way because now my mean is going to shift and my mean is going to be bigger. So now my mean is going to be bigger than my median. All right, now when we look at that as a box plot, let's look at that as a box plot. Let's erase some of this other stuff that I had here and just go back to this box plot that we had here. If my median is 18.5 and my median, I'm sorry, that we don't know our mean, and that wasn't our median. I messed that up. This is our median. Our median is 17. But since this is really long, if I drew this as a distribution, it would look like this. This little whisker is this little tail. This long whisker is this long tail. The majority, 50% of the data, from here to here is 50% of the data is in here. Our median is at 17. And we know that somehow, for whatever happened here, there was a mean that was bigger than 17 that pulled some of this data this way, making it skewed to the right. Okay, let's look at one more problem. And let's see if we can classify these. Okay, this one is skewed. Long tail on the right, skewed right. This one is skewed. Long tail on the right, skewed right. These are skewed the same. This one is pretty symmetric. It's not perfect, but it's pretty symmetric. This one, long tail on the left, skewed left. This one is a little harder to tell. But if you look at numbers, the way numbers are, you have to kind of look at this, but it should be, I'm just going to make up numbers here, but it should be that the smaller numbers are on the bottom and the taller numbers or bigger numbers are on the top. That's how it should look. So then when you do it like this, 5 to 10, you can see that the tail on the right is bigger. So therefore this is going to be right skewed. But if you were to look at it and it had numbers on it, and it was like this, which I'm not really sure why it would be like this, but if it was, and this was the smaller number, then you'd have to turn it like this, the smaller number on the left, then this would be left skewed. All right, there you go.